Hi, today is our second day of displaying and describing quantitative data. And yesterday, our last lesson, we learned how to make stem plots and dot plots. Today, we're going to learn another graph called the histogram. And a histogram is probably the most widely used graph in statistics when you're doing quantitative data. It works for all different types of data, both discrete and continuous, and it works for multiple digits, multiple decimals. This will work basically with any kind of data that you possibly have, which makes it a little more versatile than the stem plot and the dot plot, because those were limited to whole numbers or two-digit numbers, etc. So histograms are super versatile. We really like them. A histogram is simply a bar graph with special properties. You'll see there's an example of one to the right. One of the special properties is adjoining bars will touch as long as there's data in each bar. If there's a bar missing, like right here, that means that there's no data between those two values. Otherwise, as long as two intervals have data in them, they will be attached or touching. So in a histogram, we divide the data up into intervals or classes. If you think back to bar graphs, we had intervals already made for us when we'd say like blue eyes, brown eyes, or red skittles, green skittles. We already had groups. We have to make our own groups with quantitative data. So like on the picture you're looking at, they make groups of 10, so 20 to 30, 30 to 40, 40 to 50. So we need to create those groups since they're not readily given to us. Then we just count how many data points fall into each of those groups that we make, or classes we call them. And then the height of each bar shows the number of observations that fall within each interval or class. And we can make histograms that are relative frequency histograms as well, where the height of the bar would be the percentage of the data that falls in that interval. So we can make frequency histograms and relative frequency histograms, just like we did with bar graphs. Steps for making histogram by hand. We'll actually use our calculators to make these most of the time, because it's much faster and we can manipulate the picture a little bit. But you should understand the process, so we're going to make a couple here by hand. So steps for making a histogram. Create 5 to 15 intervals or classes. So that's going to determine how many bars are in our graph. Less than 5, we figure there's not enough detail that's going to be seen in the graph. And over 15 intervals or classes, or bars in this case, would probably be too much detail. So we try to keep these intervals between 5 and 15. The intervals should not overlap. So every value should only fit into one interval. Like if I had a number, I shouldn't be wondering which group do I put it in. Each number should go into only one group. Then we find the frequency in each class, which just means we count up how many of the pieces of data would fall into that group. And if it was relative frequency, we'd figure out what percentage fell into that group. Then we'll create a bar for each interval. The bars will touch unless an interval is empty. And of course, on any graph, we will label our axes so that we know what is being described by our graph. So we're going to create a histogram using our states visited data. We've already made stem and leaf plots with this, made a number of them. So we'll just take a look at what a picture would look like with that same data if we made a histogram. So first I need to make my intervals or classes. Intervals are also called classes. And one thing you could do is look at the smallest value and the largest value in your data. I have to go from 3 to 50, so I need to make sure my intervals cover all of that information. So my thought is, let's make our first interval 1 to 10. And then our second interval would start at 11 and go to 20. Now that's what I meant by you can't overlap the intervals. Okay? If one interval ends at 10, my next one should start at 11. And then my third one would be 21 to 30, 31 to 40, and 41 to 50. That will fit in all of my data. So when I make my histogram, I'm going to have the potential for 5 bars, okay, if I get data in each one of these. Now, I'm going to count how many pieces of data fall into each interval. So from 1 to 10 would be all of these. And if the data was in order, what I would do is make tally marks as I count them up. Okay? But in this case, I can just count them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's the nice thing about having the data in order, is that I don't have to go through and tally and count them up. From 11 to 20, that would be these. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 13 in that group as well. In the 21 to 30 range, I have these 3. So that's 3. In the 30 to 40 range, or 31 to 40 range, I have 1. And in the 41 to 50, I have 2. Okay. Once I have my frequencies, then I can make my histogram. So I'd make an X and Y axes. On the X axis, it would be number of states visited. And this is where I'm going to put my 5 groups of 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. Now on the y-axis, this is going to be my people or students. Each of those numbers represents a student from my class. And then I need to scale the y-axis as well. This is the x, this is the y. And what I need to do for the y-axis is make sure I can fit a bar as high as 13 on my graph. So I'm probably going to count by 5s on my y-axis. So 5, 10, 15. You could count by whatever you want as long as you can fit all the bars on the graph. Now, to make a histogram, all I do is make a bar on the 1 to 10 mark that's 13 units high. And you're just going to eyeball this the best you can. I often will write in the total above the bar just so I remember what it was. My second bar from 11 to 20 is going to go to 13 as well. And it's going to share a side with that first one. And those are the same height. I didn't do a very good job of that. Okay, and notice those 2 bars touch. The third bar is going to go to 3. And those are going to touch as well. My fourth one's going to be 1 high. It's going to be short. And my fifth bar, 41 to 50, is going to be 2 units high. And when you're doing these by hand, they're not going to be perfect, but we just want to get the overall shape. Okay, so you can see from our picture here that most students in this class, and we already know this, saw 20 states or less. And we had a few students who saw a lot of states. Okay. The shape of this graph, when we have a big group of data on one side and a small little tail on the other side, we call this a skewed graph, and it's actually skewed right. It's always skewed in the direction of this little tail, we call it. Okay, so that's a histogram. We're going to make another histogram on the next slide, and we're going to change our intervals. Okay, we only had 5 intervals on this one. We're going to do this again, but we're going to make 10 intervals. I just want to show you what happens if you make more intervals. So this time, instead of going 1 to 10 on the first one, I'm going to go 1 to 5, and then 6 to 10, and then 11 to 15, and 16 to 20, 21 to 25, 26 to 30. One thing you'll notice about these intervals as I keep making them, they're all the same width. Okay? Meaning, if I took 5 minus 1, I get 4. If I take 10 minus 6, I get 4. 15 minus 11, I get 4. When you're making the intervals, you want them to be the same width. And this would be 36 to 40, 41 to 45, 46 to 50. And then again, I'm going to count how many pieces of data fall into each one. So for the first one, there's 3, 1 to 5. For the second one, it's everything below 10, so it'd be these. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11 to 15 would be these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 16 to 20 would be these three. 21 to 25 would be these two. 26 to 30 would be 1. 31 to 35 is 1. 36 to 40, I don't have anything in that one. Then I have 145 and 150. So once I've made my counts, I'm going to make my histogram. And again, I'm going to make my show my little groups here. And I need a little bigger graph on this one. Okay, and those are my states visited. Be my label. And these would be my students again, or number of students. And then this time I need to scale my axis to 10 only, because 10 is my highest numbers. So I'm probably going to count by 5s. And then I make a bar for each one. So first one would be 3. And then I'd have a 10. And I actually have 2 10s in a row again. My 16 to 20 is a 3. So it should be the same height as the first one. Then I have a 2. Then I have 2 1s in a row. That's these two. And then I have a 0. My 36 to 30 to 40 doesn't have anything in it. So there's no bar going to be in that location. Then 41 to 45 is going to have 1. And 46 to 50 is going to have 1. So here's a situation where the bars don't touch. There's a space. And that's because that group didn't have anything in it. Okay. So this histogram shows us a little more detail than the one on the previous slide. And you could kind of think of it as, remember when we did a stem plot versus a split stem plot? The split stem plot had more detail in it. Well, making more intervals in our histogram gives us more detail. Okay. And we can manipulate that when we do this on our calculator to get a good picture of the data. Okay, and then this picture again would be skewed right because the data really stretches out to the right side. Now, histogram pros, easy to make. You can use technology, which I'm going to show you next. Okay, it's a great picture of the distribution. We can use it with any data, any quantitative data. Okay, so it really makes it versatile. Okay, the cons of a histogram: once you make the graph, you can't see individual values. Okay, if you think back to a stem and leaf plot, we could see every value in the stem and leaf plot because every number in the graph meant something. Here, you can't see the individual values once the graph has been made. What I mean by that is, like in this first rectangle right here on the graph that I'm now outlining in blue. Okay, I know that there's 3 pieces of data in there, but I don't know what they are by looking at the graph. They could be 3 1s, they could be 3 3s, they could be 3 5s. In our case, it was a 3 and 2 5s, but we can't see that detail in a histogram. Okay, so a histogram really gives you a better big picture of what's happening, but the stem and leaf plots actually showed us each individual piece of data. So that is one con of a histogram, is that you can't see the individual values. But as long as you had the individual data in the table form above, you could figure out what they were. But that is the one con of the histogram. Now I'm going to show you how to do this with your calculator. So if you follow along, I've made some screens here. This first screen is just what the calculator base keyboard looks like. And to make a histogram, the first thing we're going to do is hit the stat key. And I'm going to change to red so you can see a little better. And the stat key is in the middle of the third row of your calculator. You hit that button, and the screen should turn to the second screen here. You're seeing this. And then we want to go right into this first choice, which is edit. Okay, that's where we enter data into our calculator. When I hit that enter on that edit, I get this screen over here to the right. And what I'm going to do is go to list 1, and there's 6 lists in your calculator that are built in. Go to list 1, and you type a number in and hit enter. And then type another number in and hit enter. And type another number in and hit enter. So we'd go up to our list of data for states visited and type them all into list 1. Then our next step is to hit what's called the stat plot button. And that button is up here in the upper right hand corner. I'll draw an arrow. It's above the y equals key, so in order to get that to happen, you have to hit the second key first, that little blue key. So you hit second stat plot, you'll get this screen down here. And then we're going to go into the very first one, so you can push enter on plot 1, which brings us to this screen. Notice there are 3 plots we can make at one time using your calculator. There's plot 1, plot 2, and plot 3. They should all say off to start with. Okay. If you have multiple plots on, you can end up with errors if you're not trying to really make no more than one graph. And there's a fast way to turn them off. You could do number 4, which if you hit enter on that twice, you would turn them all off. But when we go into that first plot 1, we want to turn it on. So make sure the on is highlighted. And then there's a type of graph. We want to be sure we've chosen the one that looks like a histogram. So you move your cursor over and hit enter so that the histogram picture gets highlighted. Then the X list, we want to make sure that this says L1 because that's where we put the data. If we had put the data in L2, we'd want that to say L2. Okay? And then the frequency we can just leave as 1. That just means we're going to use each piece of data in our list only one time. And if you have a fancy calculator, you can pick the color. I don't have a fancy one, but if you did, you can choose it to make a blue histogram if you want. Then, right before you make the graph, the last thing you want to do is hit the zoom key, which is in the middle of the top row, and then do zoom 9. What that does is it sets the window of your calculator to fit the data. So anytime you make a stats graph using the stat plot, you always want to end it with a zoom 9. And you can just hit zoom in the number 9, or you could hit zoom and then page down to where it says zoom stat. But then you will get a histogram. So that's the histogram for the same states visited data. Notice it looks very much like what we did. The calculator does choose its own intervals or classes, etc. So it may not look exactly like ours. Okay, but you can see the general shape is the same, and that's what's important. Okay, when we make a graph, we're trying to look at the general shape. We can alter that shape to make it look like our graph if we want by going to the window button, which is right here. If you hit that, you'll get this screen, and you'll see there's an X min and X max. We could set those. Basically, those are the numbers on the X axis. This would be the min, this would be the max. So we could set that up to match what we did before on our own calculator. The X scale button right here, the X scale number, that's the interval width. On our graph, we made our first intervals were 10 units long. Our second one, they were 5 units long when we did it by hand. The calculator chooses kind of funny intervals like 8.1. I went in using the cursor and changed that X scale. If you look down to the next screenshot, I changed the X scale to 5. Okay, so that made my intervals be 5 units long. And then I hit zoom 9 again. Or I'm sorry, don't hit zoom 9. If you change the window in your calculator, then you just want to hit the graph button. And the graph button is right here. Okay? If you hit zoom 9, it'll revert back to the original picture that the calculator made. We don't want to do that. We just want to use this new window that we've created, so you hit the graph button. Notice now my histogram is very close to the one that we made together in class. Notice there's a gap in there. It's not exactly the same on this end because we stopped our graph at 50 and they stopped theirs at 58, so the scale is just a little bit different, okay? But it doesn't matter. As long as you get a picture that's generally looks like this, that it's skewed to the right, that's what we're trying to determine, is what's the shape of the graph, okay? So, you know, 2 people in class doing a homework assignment could have 2 different histograms, but they could both be correct because of the way you made the intervals, okay? You are welcome to stick with whatever the calculator gives you as your histogram. That is totally fine. And when you make a histogram with your calculator, what you would do then is you would sketch a picture of what it looks like on your paper. Okay, and that would be fine. And there's actually a button on here called Trace, which is right here. And what Trace does is it will put a blinking cursor on the top of one of the bars in your histogram, and then below on the screen it'll tell you how many pieces of data there were in there. Like it'll say n equals 5. That means there were 5 pieces of data in that list. And it'll also tell you the range of values that were in that interval. So if you ever wanted to know some more detail about the picture that they gave you on your calculator, just hit that Trace button, and then you can use the cursor to move around. Good luck with histograms.